Okay, so we're going to look at piecewise functions today, which are pretty similar to what we've been doing this past unit. So that's why we're not starting a unit. We're just going to do a couple things that kind of fit in with the linear functions, and piecewise is one of them. So let's go ahead and get started. What is a piecewise function? So piecewise functions are combination or pieces of one or more functions. And different parts in the domain of the function have different rules. So we can kind of break that down here. Remember, domain is just looking at the x values. And we're basically going to say different parts of my domain or my x values are going to have different rules. In other words, only pieces of my line are going to exist in certain places on the x-axis. And so we can see that here, if we want to look at the absolute value function in another way. Now, of course, we have our regular absolute value function, but we can write a piecewise function that looks just like an absolute value function here. And so let's take a look at some things going on. So two ways to write this that's going to end up being the exact same. We can have the absolute value, or we can have this piecewise notation. So let's break this down since we may not have seen this before. So remember, f of x is just saying y equals, right? And then we have just one side of fancy brackets. So this is used when we have a list of functions. So you would often see this in systems, so we'll get to that. But we also can see this in our piecewise notation here. The reason that I know it's piecewise is because I have my restriction right here. So this first part is the function itself. So this is going to be the line or the function that we make. There's two of them, right? I'll move this over here. I have two lines, two rows, and then over here, and I end that function with a comma, and then we say, okay, here's my restriction. And so let's take a look at this. So I have my line. Remember, this is y equals negative x. If I told you, think in your mind y equals negative x, you're thinking of this line right here, okay? So we have a slope of -1. It goes through 0. That's my y-intercept because it's negative x plus 0. And that would be my line in red. But here's my restriction. We're saying this line is only going to exist where x is less than or equal to 0. So we're looking at -1, -2, -3, -4, and so on. Or basically anywhere where my x's are negative, which is why we only see that negative x function appear right here. Same thing is true. The positive x function, y equals x, again, plus 0 at the end. So we're going through 0 right here. Look at what's going on. That is saying where x is greater than or equal to, or just greater than 0, right? So you can really only have kind of one that has a line underneath it if they're both. You can't have both being true at the same time, really, in this case. So you won't really see them both have double lines there. Okay, so let's go ahead and try graphing some of these and evaluating some of these. So first, let's just make sure we understand what this notation is and how to evaluate. So this is very similar to us evaluating last unit. This notation should look familiar for 1 through 4. So if I want to evaluate the piecewise function for each of the values below, we want to make sure a couple things. First, we can understand that this is what I'm plugging in for x, right? So this is saying, look at f of x, whatever f of x is, we're plugging in -4 for x. Well, then if I just was given one function, not a piecewise function, we would just be able to plug that directly into the function, right? Substitute -4 in for x, and I'm fine. But here I have something that I need to do a little bit more thinking. We want to look at the function that is existing at -4. So I don't want to look at this function that I've crossed out in red here, because look at what it's saying. 3x minus 2, that line is only existing when x is greater than 0. But my problem is f of -4. So I want to only plug it into this one, where x is less than 0. So again, this is kind of my restriction or my rule. Then this is what I plug it into. So I can substitute -4 in for x. Okay, so then again, this is an ordered pair, right? So this is y equals, we're solving for y. And so I get -2 times -4 is 8 plus 4. So that's equal to 12. And so I could write this as an ordered pair. This would be -4, 12. You don't have to do that, but I'm just saying, again, trying to put this into our minds. We did this last unit. Finding the x value, we just did it on a graph. Now I'm not given the picture yet, but I can still evaluate. So the point on that line is -4, 12. That one exists because of this piecewise function right here, right? So I'm not using that one. So now that we know that, we can go a little bit faster here. So f of 0 would be the next one. So again, I'm not including 0 right here. So this one I'm not going to use. I do include 0 right here, so I'm going to use this function, 3x minus 2. So we can say plugging in 0 for x. Again, this is the x value that I'm asked to substitute in. We're going to solve for y here. So y equals -2. And so again, that ordered pair would be 0, -2. But you don't have to write that. Just trying to make connections. F of 6. So 6 is greater than 0. So I again want to use that 3x minus 2 function. So 3 times 6 minus 2. 3 times 6 is 18 minus 2, which is 16. So 6, 16. And then number 4, f of -8. Again, we have a negative number, so I want to go back up to using this function because that's the one where x is less than 0. So we can say -2 times -8 plus 4. Again, we're solving for y. So -2 times -8 is positive 16 plus 4, which is 20. So that's just, kind of basic knowledge, making sure we still know how to evaluate, making sure we can now apply that into a piecewise function and know my restrictions, right? That these two lines are only appearing in certain places. One less than 0, the other one greater than or equal to 0. So now let's actually go ahead and graph some of them. So for this one, we have 3 functions. Okay, look, I have 3 rows, so it might be helpful at this point, and I put this on the instructions for this. But you may want to, if you haven't already, if you didn't read that, you may want out some colored pencils or highlighters, and then we also have, I didn't put colored pencils. Hopefully one of my students that I messaged put colored pencils out onto the cards, and then you may want a ruler. But you can do this with a pencil. You just may, have a little bit of a hard time kind of figuring out what is what. So I'm going to go ahead and I'll just select all my colors here at once. So I'm going to make this one blue, I'm going to make this one green, and I'm going to make this one pink. Okay, and so again, this is number 1, this is number 3, this is number 2. So I have all of my functions here. Again, 3 different ones because I have 3 different rows. And so the first thing that I want to do is, if it helps you, if this notation is like, what is going on here? It may help you to write this off to the side. Remember, g of x is the same thing as y, okay? And so it may be helpful for number 1 to really just write this as y equals -x minus 6. Because that's what this is saying. It's just that I have a list, which is why we use the fancy brackets, of all of these functions. We're putting them all together. We're saying this is all part of the function g of x. We have 3 different lines existing in different places. And so my line, this first one in blue, is really y equals -x minus 6. So it might be helpful right now to start with your pencil, because we will be doing a little bit of erasing, but then you can go over it with a color. That's what I always do. Now, I get to use the color from the beginning because I'm on my iPad, but I would use your pencil lightly because we're going to do a little bit of erasing and then go from there. And if you want to color it over with a colored pencil so you can tell what line is what, that's fine. Okay, so all you got to do is graph this like normal at the beginning. Okay, so again, use your pencil very lightly here. So we're going to start at -6, and if we need a refresher, I will write this up here at the top. Y equals mx plus b, right? So the number in front is my slope, -1, and then my b value, my y-intercept, is -6. So I'm going to start all the way down at 1, 2, 3, 4, 5, 6 right here. Maybe, hopefully my pen doesn't die. Okay, it's dying. Okay, I'm not going to be able to pause this video because I'm on my iPad, so you're just going to have to skip about like 30 seconds forwards. I'm very sorry, but I got to get my charger for this. Okay, I think that was about 30 seconds. All right, so here's my point, -6, and I go down 1, forwards 1, down 1, forwards 1. I have the slope of -1. So I would make as many points as you can. And again, connect this very, very lightly. All right, very, very lightly. And you can kind of graph it like this. All right, so very lightly with your pencil. You can maybe use a ruler or just do your best to make a straight line. And you might be wondering, okay, well, what does the piecewise part come in? So how I like to do it is I like to just make my line like regular and then just erase what I don't need anymore. So what we're saying is we have x is less than -3. So I'm only going to have this line exist less than -3 on the x-axis. So in fact, I may want to extend my line out a little bit more like this to kind of cover the page here. So we can find where is -3 on the x-axis right here. So I'm going to erase everything right here. So you want to do the same thing. You want to erase everything in front of -3 because I'm saying this line only exists when x is less than -3. So I'm going to go ahead and erase all of those points. My iPad kind of does it all at once for me, but here would be my line, okay? And so I can kind of get rid of all this. And so as we go faster here, you'll get used to kind of how we're doing this, but again, we're saying x is less than -3, so my line's going to only exist everything less than -3. And I have an open circle here, so we want to make sure to have an open circle. All right? And so I'll erase my little point there. I don't need that. All right. There we go. Okay, so there's my first line. So let's do that again. This one is g of x equals 5. Or remember, g of x just y equals 5. So I've told you not to forget about this. Don't forget about these special lines. So this is HOY. Horizontal line, 0 slope is written as y equals a number. So I'm going to just make a horizontal line through 5 on the y-axis. Because again, this is a horizontal line. So I can go up 1, 2, 3, 4, 5. So again, you want to start with your pencil. And very lightly with your pencil, just make a horizontal line like this through 5, and then now we can kind of figure out where is this line existing. So this line is existing between -3 and 4, right? We're saying on the x-axis, this line is between -3 and 4. So if you want to do a little bit of kind of erasing here, so it's going to pick up right here from -3. So I'm going to erase everything before this line, and then we're ending it at +4. So we're going to just kind of have those little segments right there. So I can erase everything around that. Fortunately for me, this is going to erase the whole line, which is why I put those barriers. But you can just use your pencil and erase what you need. And then, again, what we have is a closed circle at -3, but an open circle at +4. Again, where am I getting that from? From those lines. These still matter, okay? Closed circle at -3, open circle at 4. And then finally, the last one, we have y equals 1/2 x plus 1. Again, that's really how I'm reading this. So you don't have to rewrite this over here. I'm just doing that if this is confusing to you. So now I have it in slope-intercept form, 1/2 x plus 1. So I'm going to graph that line. Again, take your pencil on this one. Take your pencil very lightly. We're going to start at +1. That's my y-intercept. Go up 1/2, up 1/2, up 1/2, and so on. And then I can connect that. I'm thinking ahead a little bit here. I'm kind of looking, all right, x is greater than or equal to 4, so I really don't need to graph anything over here because I know we're just staying above 4 here. So again, 4 on the x-axis is right here. So I'm going to erase everything before that, and I'm just going to keep everything after 4 because we're saying x is greater than 4. And then there would be my answer. And that one has a closed circle there. So I'm going to leave my closed circle. I'll make that a little bit bigger though. All right, so there's my closed circle at 4. And so that's really it. So that's how we graph a piecewise function. So in the end, you just want to double check that you have all of your restrictions correct. Make sure you have open versus closed circles. And that's about it. So let's try to answer the question of evaluating g of -3. Now that we have a picture, it's easy to kind of look at the picture. So g of -3, we can kind of do the same thing we did in the notes for this past unit. We go to -3. If I go down, I'm at an open circle, so that's not the function that I want to use. So I go all the way up 1, 2, 3, 4, 5. So this ordered pair would be -3, 5. So the corresponding y value would be 5. If you did not have the picture, though, again, we could go with what we did earlier, and maybe this will help you to see why we get the same thing. You would say, well, where's g of -3 existing? Well, we're not including it here at -3, so that one's not going to be it. We would want to use this function. Well, there's no x to even plug it into. Y is just equal to 5. That's my function. There's no x. So no matter how you decide, just by either looking at the function or evaluating with the picture, you're going to get 5, okay? So let's go ahead and now go in reverse. Now I'm going to give you the piecewise function, and then you're going to graph it, okay? Or write the graph, write the equation for the graph, okay? So again, this one was, we're taking the equations, making the graph, now we're going in reverse. So it may be helpful if you want to have your color pencils or your highlighters out. I'm just going to use different colors here, so sometimes people write in colored pencils what their functions are in different colors here, just so we know. But you don't have to. It's just sometimes people like to make their notes look nice. And I'm going to do that, so you can copy me. All right, so I have blue, pink, green, and orange, and I'm just going to go in that order. I'm working from left to right. It doesn't matter. You can have your functions in any order. It just will look more, it'll look more correct if you have it going from left to right, because then your restrictions are going to be in order, right? Notice how all my restrictions are in the right order. If you're jumping around, your restrictions are going to look kind of weird. It's not wrong, it's just not the most correct. Okay, so let's start with the blue one. So I just want to write the equation of this line. I want to know, what is this line in slope-intercept form? So I can just pick any 2 points on this line. Here's some 2 good points. Again, this, I know that the arrow is pointing down. So we're tempted to say that this is a negative function, but let's say I got rid of this arrow. This is a line that is positive, right? I'm walking up this line. So this is a positive slope. I'm going up 1, forwards 1, 2. Ignore the arrows. That's what's telling me my restrictions. So my slope is 1/2. The y-intercept, I don't know. I can keep graphing it though, right? I can keep going up 1, forwards 2. That would be the next point on this line. So I can kind of extend that out. The y-intercept to this line would be -1. And so there would be my full answer in slope-intercept form. So remember, the y equals part is already written for you. That's h of x equals. You're just writing the rest. So 1/2 x, again, that's the mx part. My slope was 1/2, plus b. Plus b is my y-intercept. That y-intercept is -1. So there's the first part. We put a comma to show that I'm ending my function. And now let's look at my restrictions. Where is this line existing on the x-axis? Well, right here at -2. It looks like my graph goes from -infinity, right? We're going all the way to the left until we get to -2 on the x-axis, okay? So we're going to say that all of my function here is existing where x is less than or equal to -2. I'm using less than or equal to because of that closed circle there. So these arrows should match up, right? That's an arrow pointing to the left. I'm using my less than sign because we're heading towards -infinity. So everything less than -2, right? -3, -4, -5, -6, and so on, all the way down. Okay, so now let's move to our pink function. So our pink function, we have, okay, here's my paper. All right, so this one is a very easy one. This is a special line, okay? So this is a horizontal line. Remember, we just write those as y equals the number, whatever the number that it goes through on the y-axis. Well, it goes through 4 on the y-axis, so we're just going to say y equals 4. Again, I don't need to write the y equals part. It's already here. So 4, comma, and now I can write my restrictions. Where am I staying between on the x-axis? Well, I start at -2, and I go all the way to +2. Both of them have open circles, so that's exactly how I want to write that. -2 to +2. And there's how we write our interval, right? X is in between because we're saying this is existing on the x-axis in between -2 and +2. Okay, so let's go to the green one. The green one, same thing, except if I wanted to extend this line is really y equals 6. Now, all of those y values are at 6. I'm not moving up or down. So this one, we start at positive 2 and go all the way to positive 6. So I go from 2 to 6 on the x-axis, but that line is y equals 6. So I'm just going to write 6 here. Again, I'm going from 2 to 6. I have a closed circle at 2, though, so I want to use that symbol there. And then finally, the last one in orange, okay? So the last one in orange. We kind of run into an issue here. Well, first, let's find the slope. That's the easiest part, right? Because this one is not just a straight line anymore, so I really do have a slope and a y-intercept. So here would be a good point on this line. Here would be a good point. So there's lots of good points. So it looks like I'm going down 1, 2, 3, forwards 1. So my slope is negative 3. If I tried, you can do a couple things here. You may notice that if you try to extend this line out to the y-axis, you're not going to get there on this graph. We don't have enough room. So I can go up 3, backwards 1. I can go up 3, backwards 1. I can go up 3, back, and I'm very far away from finding my y-intercept. So we're kind of like stuck here. We're like, okay, I can find my slope, but I can't connect this line back to the y-intercept so easily like I could for that blue line. Well, this is where we need to use our knowledge of everything that we did last unit. I know the slope of this line, and I know many points on this line. So if I want to write the equation of this line, I have to go into point-slope form now. So point-slope form, again, is useful if you're not able to identify the y-intercept of a line like this one. My piece is so weird that I'm not able to find the y-intercept just by looking at it visually. So let's just pick a point. I can just pick this point right here. So I'm going to use, what is this one? 6, 2. So there's my point that I'm going to use. Again, I just identified my slope to be negative 3. That's enough information to write an equation of a line just in point slope form. So if we need a reminder, point slope form is y minus y1 equals mx minus x1. So let's go ahead and plug that in. So we have y minus 2. That's the ordered pair from that. Slope is negative 3 times x minus the x value from the ordered pair is 6. And then I can just quickly solve here. So I'm going to go pretty fast since we've done a lot of stuff like this the past unit. So I get y equals negative 3x plus 20. So again, I would have not been able to figure that out, right? Plus 20 is double this coordinate plane. I would have been like way up here or something. So when I write this, I just want to write the negative 3x plus 20 part. And then now I can say, well, where's my restriction? Okay, so that was me writing my line. I just kind of had to go the long way, negative 3x plus 20. And then where does this line exist? This line exists starting from positive 6, closed circle. My arrow goes forever to the right. It's going down. This is why I have that negative slope. Because we have that negative slope. We're going down forever, but we're also moving to the right forever. So I'm going to write that now. So we have x is greater than or equal to 6. Just going to look at 6 on the x-axis. We're greater than, we're moving to the right forever. And then if I wanted to evaluate h of 2 would be right here. Again, I'm finding where we at on the x-axis. I go right through this open circle that's not part of my line. Where I'm at h of 2 is up here at 6. That ordered pair is 2, 6. So there would be my answer for that one. Okay, you don't really need to show any work. If you chose the other way, again, you would have been looking at this one, which is just 6 as well. Nothing to plug in for x. All right, so your homework today is a couple pages. I put day 1 and day 2 notes together. So your homework looks like this. It doesn't say homework. It just says A2 blank. And then it says day 1 linear and constant piecewise functions. So this is your homework. You have some, it looks like it's a lot more than what it is, but you have some evaluations like how we did on the first page of notes. Then you're going to graph all of these. And then we have this down here, okay? So on the answer key, I kind of helped you out a little bit with some of them, which is why you saw that down there. So you may want to check out the answer key just a little bit for some hints since I'm not there. But this is due Wednesday. Also, if you're still listening, if you want a little bit of extra credit, let me know what the score of the Bengals versus Chiefs games was last night for extra credit. Post that in the private comments of this assignment. And I'll give you extra credit. All right, I think that's it. So if you guys have any questions, feel free to email me today.